Hi, everyone. It's Judy Warner. Welcome back. So glad to have you again in this week's OnTrack podcast. Today, we have a returning guest and friend, Ken Wyatt of Wyatt Technical Services. Ken has over 30 years experience in EMC, troubleshooting, compliance, and all kinds of expertise, starting at HP, then at Agilent, which is now Keysight. And for the last 13 years, he has been running Wyatt Technical Services. He's going to teach you about some tips and tricks to help you troubleshoot your EMC issues right from your own workbench, and talk to us about a new book that he just came out with. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Ken. Welcome back, EMC Doctor. We're glad to have you again.
Thank you very much. Glad to be here.
Well, I wanted to get you back on, Ken, because you and I were chatting recently, and you were talking to me about some of the things you've been doing sort of during this COVID era and how, something that seems to consistently come up and a sort of a pain point you like to address with design engineers is around actually a topic that you're passionate about and you wrote a book about, which I believe is called Create Your Own EMC Troubleshooting Kit. So why don't you tell us a little bit about what inspired you to write that book and sort of what you're seeing in these maybe commonly held myths or things that people don't know that they can simply do right from their own workbench?
Well, good questions. And what I see very commonly in my clients, and even when I was working for Hewlett-Packard and Agilent, there's some common design issues that just seem to be prevalent, no matter what the product is, no matter who the client is. And that can include cable shield issues, not knowing where or how to connect the cable shields, can consist of PC board issues. Turns out that the PC board is really a key factor in reducing EMC issues, and very often the stack up is wrong or the routing is wrong. Another problem with PC boards is a lack of solid return planes. I see that very often in 2 and 4 layer stack ups. Mm-hmm. So those are some areas that are just common issues with a lot of my clients. And so the reason I decided to write these 3 volumes, and as you mentioned, volume 1 is already out, available on Amazon. And it includes the tools, equipment, probes, and other accessories that engineers can use right on their workbench to evaluate what the EMC characteristics are of their product, and actually do some troubleshooting. And so that's that was really the impetus for developing these 3 books. The others are in the works. We'll get to that, I guess. But it's just it pains me as a consultant, even though I make money doing this, to see the same old problems over and over. And so and of course, one of the problems is that EMC is not really taught in the universities or colleges in most cases. There are some universities that do teach it. University of Missouri is a good case in point, but most designers have to learn this the hard way. And I I'm trying to help them get educated.
Yeah, I think you're on to a good point there. It's typically not taught. And a few weeks ago, I don't know, a month ago, maybe I did a podcast with Todd Hubing, who happened to be at University of Missouri. So I'm sure that's where some of that's coming in anyway. So
Yes, yeah.
we're in good company, Ken, with people trying to get that information out. Well, that's exactly why I wanted to have you on today. So you mentioned stack ups, which is always a shock to me, but I've heard this from people like Todd Hubing, from Rick Hartley, from Eric Bogatin about the stack up issue. And gosh, like you said, it's painful, and it sure would be nice to, all we can do is get this information out, right? So what are some other blind spots that you see that are common, and maybe a couple points that you bring up in your book are things that for design engineers to think about relative to EMC that they might not be aware of?
Well, I mentioned cables. Cables are usually a big offender. They're long. They look like antennas, and if any EMI noise currents get on them through lack of filtering or poor PC board design, they're going to end up radiating. Not only radiating for radiated emissions, but they can receive external energy sources like electrostatic discharge, and two-way radios and things can affect your circuit because they act as receiving antennas just as well as transmitting antennas.
Wow.
And cables are a problem. The connectors associated with cables can be an issue, and this whole issue with PC boards. I think engineers generally look into the past to see what the recommendations are for things like stack up, and
Yes.
in most cases, the advice, even in some prominent books, is not always accurate. And so Rick Hartley and Dan Beaker and others are trying to bring in more of the physics of EMC
Yes.
for better understanding.
Yes.
So those are the most common issues I see.
So give us a scenario of, like, if it's modeled badly, or you hit one of these blind spots, or you don't have a solid ground plane, how does that usually play out practically for a design engineer?
Well, normally you would expect radiated emissions issues. So, a fast trace or a clock trace over a split in the return plane is going to create common mode currents, which are then going to propagate all over the board and couple into cables, and so that's a very common design issue that I face a lot.
So did it end up, just, this is my sort of ignorance here, not being a design engineer. So say they have this, they design the board, they have the board made, they populate the board, and then they begin testing it for EMC compliance, or, how does that fold out? And then at what point do design engineers get to this point and go, uh-oh, something's not right? And then think, well, what do I do now? And how does that troubleshooting, how do they identify actually where it's coming from?
Well, that's a good point. And so usually EMC is kind of a last minute thing. They'll send their baby off to the compliance test lab, and they'll get failures for ESD or radiated emissions or whatever it is. They'll go back because they don't understand the physics of what's happening, or the basics of EMC design. They'll throw some ferrite chokes on the cables and some other, grounding and bonding and so forth, and it may help. It usually doesn't, and so the issue is, from their point of view, they're back and forth between their facility and the test lab trying to troubleshoot something they don't really understand. And so that's really the main reason that I've decided to write these books. So volume 1 is just really a starting point. It describes choices in equipment and probes and that sort of thing. Volume 2 is going to talk about radiated and conducted emissions, which are, the radiated emissions is really the number one issue that people face all the time. And so I've developed a 3-step process for identifying the energy sources on the circuit boards with near-field probes. Once you understand the EMC characteristics of each of your energy sources, like DC to DC converters, microprocessors, memory, various clocks on the board. Once you understand that, then you take a step 2 is take a current probe and start measuring your cables and see if there's any relationship in the EMC characteristics you see on the cables back to the energy sources. And so there you might get some kind of you might understand the coupling between the energy source, whatever it is, and that cable. And then the third step is to set up a nearby antenna. And it doesn't have to be a tuned antenna, just a hunk of metal, really, is what I tell my seminar attendees. As long as it can receive the actual transmitted or radiated signals, then you can start troubleshooting in real time and watch the spectrum analyzer as you go. So volume 2 will have all my secrets on all the Workbench troubleshooting I and others have developed through the years to be able to characterize, measure, and add some mitigations right at the bench level, so you don't have to keep going back and forth between your own facility and the compliance test lab. The test lab is not the place where it's very efficient to do troubleshooting. So
right.
Hopefully these books will help.
So, you mentioned a spectrum analyzer, and I know you worked at Agilent, which is now Keysight. And I've seen some of those spectrum analyzers, and they're not cheap. So
a good lab grade analyzer can be in the tens of thousands of dollars or more.
Yeah.
The neat thing about setting up your own troubleshooting bench is you don't need the top of the line spectrum analyzers or oscilloscopes for the most part. And so I give choices in volume 1 on everything from $1,000 spectrum analyzer to maybe higher priced choices with a little more features, such as real-time spectrum analysis, which is valuable in certain applications. And so it gives I'm hoping it gives the companies some choices, but you can actually set up a pretty decent test bench for under $5,000.
Well, and my mind goes to so many people are working remote. I know proximity to a lab has been a little tricky to manage during these times, or people having to either go into their company labs or rely more. And so I'm thinking this is probably really timely for your book to come out. What kind of things are you seeing as you're teaching classes or consulting with your clients?
Well, yeah, your point about working from home is definitely something we've all had to learn how to do
Yeah.
over the last year. And it's much more affordable to set up your own home lab these days. There's companies that have very affordable equipment now, and that's all explained in volume 1. But yeah, so things I'm seeing, I'm actually working with clients that have purchased volume 1 and are using that to start building up their own EMC troubleshooting benches. So this whole idea of uh, setting up a bench level test was really an idea from Henry Ott. One of his early seminars was workbench troubleshooting, and one of the things he featured was an EMC crash cart, which was a mobile cart with a spectrum analyzer on it, some probes, and some other mitigating things like ferrite chokes and copper tape and so forth. And we actually put a crash cart together at Hewlett Packard back in the mid 90s, I think. And so that really got me thinking, especially once I got out consulting, how can I help my clients basically do the same thing, maybe not with a mobile cart, but set up their bench so that it's conducive to doing some serious troubleshooting. The techniques which I explain are pretty simple if you just understand basic electronics, and so I'm hoping the series of 3 books is going to be a help to the design community in general.
Well, I love when folks like you or whoever, Dan Beaker, Rick Hartley, even Henry Ott, which all of these folks have cited as, really having a huge impact on their career. I love when you guys put this information out there because I see the same pain points you do, Ken. And it's like, gosh, does everyone have to individually learn to create the same wheel over and over again? It's painful. And I think we all have sort of a passion to, stop the bleeding. It seems unnecessary. And so that's why I love my job to do this, is because I get to put people like you.
I love this job too. I'm turning 70 this weekend, and there's going to be a time when I and others that are really experienced are going to want to quit doing it.
Yeah.
So I'm hoping I can leave something behind, for others to pick up and take off with it.
So as of this recording, your second book, which is called Radiated and Conducted Emissions, correct?
Yes, EMC troubleshooting for emissions, and
Okay.
it'll include both radiated and conducted, and it'll have test setups for not only general products but military as well. So we're going to include military and aerospace setups. Really, the troubleshooting is the same no matter what industry sector you're in. The physics is the same. So
right.
But the test setups are going to be different. So we talk about automotive and military and then commercial test setups in that book. And we'll do the same for the immunity book, volume 3.
So for our listeners, just so you know, I'm going to put Ken's website below where you can find the book? You got the book? Oh, there it is. So for you watching on YouTube, you'll see that Ken's showing volume 1 of his book, and I have put up a link to his author page on Amazon, and also the links to his book are on his website. So make sure to go check those out after the podcast, and go save yourself some trouble, you guys. That you will, as my daughter says, your future self will thank you.
Yeah, well, I hope so.
Yeah, that's the goal anyways. So you just mentioned, Ken, volume 3. So this is a 3-volume set. And you mentioned that the volume 3. So for our listeners, volume 2 should be out in May. That's correct, Ken?
That's the goal. It's the draft is out for technical review last week, and I expect to get some responses by the end of this week. I'll be incorporating those and getting it submitted to Amazon. I hope it will be released about mid-May is the goal.
Okay, so May 2021, the book's out, you guys. So
Yes.
Make sure you go find that. And then volume 3, you probably want to, bonk me on the head for mentioning volume 3 when you just probably are taking a breath after finishing volume 2. But you mentioned it's going to be on immunity testing. Well, maybe our listeners know what that is, but I don't. So what is immunity testing, and why is that important for design engineers?
Well, these days it's important to be able to design your product to withstand both emissions, so you don't interfere with radio and TV and other communications, but immunity as well. Things like electrostatic discharge is a big one. Another big one is radiated immunity. So close by two-way radios, we don't want your product getting disrupted. There are other immunities like power line immunities, for example, electrically fast transient, which is it's a test that simulates a light switch or turning on and off, or a motor starting up, and it produces a burst of spikes in the power line. And then there's conducted immunity, where we couple RF energy directly into cables, IO and power cables. So you really want to be able to design your product to withstand all those kinds of immunity issues. Especially the top two that I run into all the time is electrostatic discharge, or ESD, and radiated immunity. I've had so many clients. There's one client of a medical product. It was a blood analyzer, and it had a series of motors that would pump. You'd run a plastic tube through these pump motors, and it would pump blood out of the patient and analyze it and then put it back. And during their radiated immunity test, two of these motors took off at 10,000 RPM. I don't think I'd want to be the patient that.
Yeah.
And the frequencies of where it was susceptible was right in the cell phone band.
Oh, so my goodness.
That's not good.
Your cell phone as a vampire.
Oh boy. Yeah, suck the blood right out of you.
It sucked the whole blood out. For
this client had been working on this problem for weeks. And so one of the techniques I'm going to demonstrate or describe in volume 3 is how to induce these RF immunity issues with just some simple test equipment. I was able to come in with basically a signal generator, a small RF power amplifier, and couple that to a loop probe and probe around inside their system. And as soon as I got close to those two motors, they took off. And so we were able to troubleshoot it and mitigate it within 2 hours. And they've
And
been
how
working
long had they been working on that?
they were working weeks trying to shield and bond and so forth, put ferrite chokes on and stuff.
You know, I've heard this before with just like throw ferrite at it.
Right.
Shields, ferrite,
Sometimes that works.
you know, like the catch-all, because we don't know. But what I hear you saying is, one, how frustrating. Two, how expensive,
Mm,
right?
yeah.
And like beating your head against the wall. So anyways, I know I'm a
So
little geeky, but I'm pretty excited about your books for for our audience.
yeah, this is my EMC troubleshooting trilogy.
So this is you leaving behind all that hard-won wisdom and your techniques. So
Well, it's myself and a lot of others have
mhm.
come up with some of these tricks, and I'm trying to put it all in one place.
I love it. Well, before I
That
let you go, Ken, what were you going to say?
that book is volume 3 should be out sometime early summer.
Oh, so
I'm
you're
guessing.
really going at it. You've
Yep.
been writing a lot, it sounds like. Okay, well, will you come back on and tell us about that one when it's out? We can
I'd love
discuss
to
it.
do that.
Okay, great. Well, before I let you go, do you have any more interesting use cases?
Um, I developed an interesting way to trace ESD current. ESD is another one of those issues that's really hard to troubleshoot because you don't know exactly the path that the ESD is taking, but somehow it's disrupting your circuit. And uh, it's possible to take a loop probe and your oscilloscope and inject a controlled small amount of ESD from an ESD simulator
Mm-hmm.
into the product where it's susceptible, and then start tracing with the probe and looking at the scope to see the pulse.
Mm-hmm.
And once you have the dominant path of current, and the ESD current can approach over 30 amps briefly. So
Hmm.
it's really it's not there for very long, but you can, once you have the path of ESD current, then you can start diverting it or blocking the current and
Right.
diverting it away from your sensitive circuitry. So that's going to be also a trick that's in volume 3. So I'm
Okay.
looking forward to getting that written.
So, Ken, we originally had the pleasure of meeting at DesignCon forever ago, it seems. Do you have any plans to do live classes? It seems that some people are trying to have in-person meetings. Do you have any plans in 2021 to get out there, or are you sort of holding off for
Well,
2022?
I've committed to attending a DesignCon this year. I'll be doing my 3-hour tutorial and a couple other shorter talks. So we'll see how it goes. I hope it's better attended uh,
Yeah.
than we hope. But
When is DesignCon this year?
I believe it is September, towards the end of September. Could be wrong.
Okay. I'll hunt down that date for listeners and I'll throw that in the show notes as well.
But in the meantime, I do plan to continue with my web-based seminars monthly, starting this spring.
Great. And again, for our listeners, you can go find that on Ken's website. There's a lot of
Yeah.
good resources for you there and technical papers and all kinds of goodies. So make sure you go check out his website as well as his books. Ken, many who do what you do have belonged to the IEEE EMC Society. Is that something you've been involved in as well?
I have. I have no idea how many years, probably 25 or 30,
Yeah.
30
So
years.
they typically have an annual event. Is there any plans on deck for that you know of?
This year it's going to be virtual. Last year it was virtual. We're hoping a year from now, it might be a live event. We're hoping.
Okay.
The one thing we really miss is being able to talk to vendors and see what's new and so forth.
Yeah, of course.
Not to mention all the workshops. So
Yeah, of
looking
course.
forward to that. And I believe
Yeah.
that's in August.
Okay, well, I'll go hunt down that link as well because I think for our listeners, those might be some additional resources they'll want to tap
Yeah.
into.
Yeah.
And
Yep.
they can meet fabulous people or learn from fabulous people like you and Todd Hubing and Eric Bogatin and so many others. So, well, Ken, thanks so much for joining and best of luck on your book. And thanks for coming on and sharing some
Oh,
of
my pleasure.
your great knowledge and your experience. So
Always nice to talk to you.
always
So,
nice to talk to you and learn from you.
yeah.
So thanks again for joining. We're going to have you back again when the immunity testing book comes out and you can share some more of your wisdom.
I'd be delighted. Thank you.
Yes, thank you. To our listeners, thanks so much for joining today. I hope this has been a valuable resource for you. Make sure you go check out the show notes. We're going to pack in a lot of good stuff for you there. Thanks for joining us today. We'll see you again next week. Until then, remember to stay healthy, stay safe, and always remember to stay on track.